Hello, this is Jack. In this session, we will take a look at the terminology defined in ISO21434. An asset is defined as an object that has value or contributes to value. In other words, an asset refers to a target within the system that needs to be protected. It is something that could be targeted by a cyber attacker or could be affected if an attack occurs. Examples of assets include data, functions, and interfaces. Cybersecurity property refers to the characteristics or attributes of a system that are worth protecting. In simple terms, these are the critical elements that need to be safeguarded against cyber attacks. ISO CE 21434 defines the key cybersecurity properties as confidentiality, integrity, and availability, which are commonly known as the CIA triad. Let's take a closer look at each of these properties. The first property is confidentiality. Confidentiality means protecting information from being disclosed to unauthorized persons or systems. For example, encrypting vehicle encryption keys or restricting access to user personal data are ways to ensure confidentiality. If confidentiality is compromised, an attacker may gain access to sensitive information and misuse it. The second property is integrity. Integrity refers to protecting data or systems from unauthorized modification. For instance, if an over-the-air OTA update file is tampered with by a hacker, malicious software could be installed in the vehicle. Ensuring that the data remains unchanged and maintaining its original state is how integrity is preserved. The third property is availability. Availability means ensuring that systems and data are accessible to authorized users when needed. If a hacker launches an attack on the vehicle's communication network, it could cause a system outage, making critical functions such as brake control or ADAS unavailable. Securing availability is essential to prevent such situations. Today, let's talk about damage scenario. A damage scenario refers to an adverse consequence involving a vehicle or vehicle function and affecting a road user. In simple terms, it describes the actual harm or negative impact that could happen to drivers, passengers, pedestrians, or other road users. If a cyber attack or system failure occurs, it's not just about a system malfunction inside the vehicle. It's about how that failure could lead to real-world consequences on the road. For example, if brake control signals are manipulated, the vehicle may fail to stop properly, causing a collision. If ADAS sensor data is falsified, the lane-keeping system might malfunction, leading the vehicle to drift out of its lane and possibly crash. If the remote start function is hacked, the vehicle could move unintentionally, putting nearby pedestrians or other vehicles at risk. If the emergency call system is disabled by a denial of service attack, rescue services may not be notified after an accident, delaying emergency response and increasing potential harm. So, why is understanding damage scenarios so important? Because they help us answer a key question. What could happen to real people if a threat materializes? In the threat analysis and risk assessment, or TERA process, we don't just identify threats. We assess how those threats could impact safety and security in the real world. By analyzing damage scenarios, we can evaluate the severity of risks, prioritize the necessary cybersecurity measures, and ensure the system design includes effective protections to prevent harmful outcomes. In summary, damage scenarios are essential for connecting technical cybersecurity risks to their actual effects on human safety. In ISO CE 21434, the term item refers to a component or a set of components that implements a function at the vehicle level. In other words, an item is not just any individual part, it is defined by its role in delivering a complete function within the vehicle system. The key point here is the phrase vehicle-level function. If a component or a group of components is responsible for realizing a function that operates at the level of the entire vehicle, it is classified as an item. However, if it does not implement a vehicle-level function, it is simply considered a component. To make this clearer, let's look at an example. The Advanced Driver Assistance System, or ADAS, is an item because it performs a vehicle-level function that supports the driver. ADAS may include various sensors, electronic control units, and software modules. But those individual sensors or control units by themselves are classified as components, not items. Since they do not independently provide a complete vehicle function, this definition of item is adapted from ISO 26262, where the original term system was replaced with component in the context of cybersecurity. Understanding what qualifies as an item is essential because the scope of cybersecurity analysis, such as threat analysis and risk assessment, is often defined at the item level. This helps to ensure that cybersecurity activities focus on the correct system boundaries where the actual vehicle level functions are implemented. Now, let's talk about threat scenario. In ISO21434, a threat scenario is defined as a potential cause of compromise of cybersecurity properties of one or more assets in order to realize a damage scenario. In simpler terms, it describes how an attacker could compromise certain assets and which cybersecurity properties could be affected, eventually leading to actual harm or damage. It's important to understand that a threat scenario is not just about listing possible attacks. Instead, it explains how a specific attack could happen, which asset is targeted, which cybersecurity property is compromised, and how this connects to a damage scenario, the real-world consequence. Let's take a few examples to make this clearer. Imagine an attacker remotely manipulates the brake control signals of a vehicle. In this case, the asset is the brake control signal. The compromised cybersecurity property is integrity. And the result could be that the vehicle fails to stop, leading to a collision. This is a classic example of a threat scenario leading directly to a damage scenario. Now, let's talk about the definition of cybersecurity in the automotive field. According to ISO21434, cybersecurity refers to the condition in which assets are sufficiently protected against threat scenarios to items of road vehicles, their functions, and their electrical or electronic components. In simple terms, cybersecurity in road vehicles means that the important assets within the vehicle system are protected well enough from potential cyber attacks that could target these assets. Here, the term assets includes anything of value that could be the target of an attack. This may be data, functions, interfaces, or physical components like ECUs or sensors. The term items refers to the systems or combinations of components that implement vehicle-level functions, such as brake control systems, ADAS, or infotainment systems. The threat scenarios describe the possible ways in which these assets could be attacked or compromised, and how those attacks could lead to damage scenarios that affect road users. The key idea is that cybersecurity is not just about preventing attacks in general. It is about ensuring that, even when threats exist, the system remains safe because the assets are properly protected. ISO 21434 also mentions that, for simplicity, the term cybersecurity is used throughout the standard instead of the longer phrase road vehicle cybersecurity. However, it is important to remember that whenever we say cybersecurity in this context, we specifically mean the cybersecurity of vehicles, their functions, and their electronic components. In summary, automotive cybersecurity is about making sure that critical vehicle systems are protected from cyber threats, so that the vehicle can operate safely, reliably, and securely, protecting not only the vehicle itself, but also the drivers, passengers, and other road users. This is why cybersecurity has become such a crucial part of modern vehicle development.